welcome to the deep dive. Our mission here is, well, pretty straightforward. We take a whole stack of source material articles, research papers, maybe even your own notes if you send them in, and we really dive in.
Yeah, we try to pull out the absolute crucial bits, the key insights, basically giving you a shortcut to being well-informed without having to wade through everything yourself.
Exactly. And for this deep dive, we've got a really interesting mix. We're starting with an AP News piece that looks into the world of microdosing psychedelics. It explores, what people are actually doing, the effects they claim, and what science is beginning to figure out.
And then we're making quite a shift. We're going deep into some pretty technical medical science. A research paper from ACS Medicinal Chemistry Letters about developing new types of drugs, small molecule inhibitors for cancer immunotherapy, specifically targeting that PD-1, PD-L1 pathway.
Right. Very different. And then we zoom out again, back to AP News, for a look at geopolitics. A recent visit by U.S. lawmakers to Taiwan, which happened just days after their new president took office, and of course the reactions that followed.
So yeah, on the surface, microdosing, complex cancer drugs, Taiwan politics, they seem pretty disconnected.
Definitely. You might be thinking, how on earth do these fit together? And look, topically, they are very different. Personal wellness, molecular biology, international relations.
But the thread connecting them, I think, is how we need to approach understanding them. Whether it's someone's personal experience with a substance or complex scientific data or the statements and actions in geopolitics.
It all requires a really careful look at the information, doesn't it? Getting past the surface claims or assumptions.
Exactly. We're looking at claims versus evidence, potential benefits versus proven effects, stated intentions versus how actions are perceived, all that good stuff.
So stick with us. We're going to journey from these personal wellness claims around microdosing, then get into the nitty-gritty of designing cancer therapies, and finish up with this snapshot of a key international situation. Our goal is to pull it all together and help make sense of it for you. Ready?
Let's do it.
Okay, first up, microdosing. Our sources show this is, well, it's not just some tiny fringe thing anymore. It seems to be gaining quite a bit of momentum, especially for people looking for ways to, feel better.
Right. We're talking about individuals taking really small, sub-perceptual doses of psychedelics. Psilocybin mushrooms seem to be the most common, but also LSD.
And why are they doing it? The article suggests it's pretty broad. A lot of people report trying it to help with things like anxiety, stress, depression, common struggles.
But others are looking for something maybe more positive. They claim it helps them find more joy or boosts their creativity or gives them this deeper sense of connection that they feel they're missing otherwise.
It's really important to nail down what microdosing actually means here. The key is the very small amount. It's specifically a dose that's not supposed to cause a full-on psychedelic experience.
Right. No visions, no major shifts in consciousness. If you're seeing the walls breathe, you've definitely gone past a microdose by this definition.
And it's not usually taken every day either. It's intermittent. Maybe people follow a specific schedule like, 1 day on, 2 days off, that kind of thing.
Oh.
Or they just take it when they feel they could use a bit of a lift.
The AP article actually gives us a specific example, which helps make it more concrete. It features Matt Metzger, who is a Marine Corps combat veteran living up in Olympia, Washington.
And he microdoses psilocybin. He actually grows his own mushrooms for it.
Yeah, and the article apparently had photos. I haven't seen them, but it describes him with his mushrooms, preparing these small doses, maybe in little capsules or baggies. It really shows this is a hands-on practice for some people. They're managing their own supply, their own dosage.
And his description of how it feels, it's quite striking. He talks about feeling, quote, viscerally in your body, a new way of being, a more healthy way of being, and also feeling more present.
Those aren't small claims, are they? Feeling viscerally different, more present. It suggests a pretty significant shift in experience that users like him attribute directly to the microdosing.
So, yeah, the user counts are really compelling. Feeling better, more grounded, more creative. Who would want that? But then comes the science, and it gets complicated fast.
Right, because how do you scientifically measure these very internal subjective states? The article really emphasizes this challenge. Belief and expectation are incredibly powerful. They're tangled up with whatever the substance itself might be doing.
And this leads to one of the most, I think, fascinating findings mentioned. A small study looked at people who already microdosed. They tracked them for 4 weeks.
And they found improvements, right? On psychological measures, mood, focus, general well-being.
Yes, they did. But here's the kicker. The improvements happened regardless of whether the participants got actual microdoses or just empty placebo capsules.
Wow, so both groups felt better.
Both groups reported feeling better, pretty much to the same extent.
That's a really big finding. It doesn't necessarily mean the microdose does nothing chemically, but it strongly suggests the placebo effect. Just the belief and expectation of getting better could explain all the benefits seen in that particular study.
It really forces you to question what's driving the reported effects. Is it the molecule or the mindset?
The source does mention another small study, this one looking at low doses of LSD, specifically in people with mild depression, and it found, quote, glimmers of an effect.
Glimmers. Okay, so not exactly definitive proof.
No, but hints of some positive impact on things like vigor and elation compared to the placebo group. So maybe something there, perhaps specific to LSD, or that context, it's not clear.
And this difficulty in pinning down an effect is echoed by a researcher quoted, Harriet DeWitt from the University of Chicago. She points out how hard it is to measure because any potential benefits may only work in some people and not in other people.
Right, that individual variability is huge in anything related to mood or cognition. What works wonders for one person might do nothing for another, which makes designing studies really tough.
Still, despite these challenges, the strong placebo effect, the individual differences research is continuing. The article mentions an Australian company doing early trials with LSD microdoses.
Oh, yeah. For what conditions?
They're looking at severe depression and also in cancer patients who are experiencing, significant despair, really tough situations where new approaches are desperately needed.
That's interesting, especially since, as you said, psilocybin seems to be the most commonly used substance for microdosing. The source cited a RAND report estimating maybe 8 million users in the U.S. in 2023.
And half of them microdosed the last time they used. That's a huge number.
Yet the article explicitly states there's a lack of rigorous large-scale studies specifically on psilocybin microdosing itself. Lots of work on higher therapeutic doses in clinical settings, but less on this specific practice.
And there's the whole legal dimension, which is messy.
To say the least. These substances are still Schedule I federally in the U.S., illegal in most places worldwide. That obviously creates massive hurdles for research and for users.
But there is movement, right? Oregon and Colorado have legalized supervised psychedelic therapy. That's different from DIY microdosing. It's with trained facilitators, higher doses.
Right, a very different model. But it shows a shift in thinking. And some cities have decided to deprioritize arresting people for simple possession, not legalization, but it lowers the risk for individuals.
So it's this weird tension. Illegal status, growing user base, some therapeutic legalization, patchy enforcement.
And alongside all the potential benefits people talk about, the source is careful to include some really important warnings.
Yeah, number one being, we just don't know the long-term effects. There haven't been studies tracking people microdosing for months or years. We simply lack that data.
That's a big one. And then the practical risk of getting substances from an unregulated market. You don't know what you're actually getting. Could be contaminated, could be a different substance altogether. The dosage could be way off.
And even if you trust the source, there's the risk of just misjudging the dose yourself. Taking too much accidentally could lead to a really unpleasant, maybe frightening experience, even if you were aiming for a microdose.
It's not entirely the Wild West, though. The article mentions a support network called the Fireside Project.
Oh yeah, the nonprofit offering free phone support.
Exactly. For people having difficult psychedelic experiences. And apparently, they get hundreds of calls specifically from people who are microdosing, which tells you that even at these low doses, people can run into challenges or just need someone to talk to.
The founder, Josh White, even shares his own experience microdosing iboga, LSD, framing it as a way to, quote, continue to deepen the insight about my life gained from previous full-dose experiences.
So for him, it's more about integration and ongoing personal growth, not just symptom relief, another perspective.
And let's circle back to that placebo idea. Balazs Szigeti, who is involved in that key study we mentioned.
From UCSF.
Yeah. He's quoted suggesting that microdosing could actually be seen as a way people harness the placebo effect. He called it a kind of self-fulfilling prophecy.
That makes sense. If you're enthusiastic, you expect positive results, you're doing this intentional ritual, maybe that itself is the active ingredient, or at least a major part of it.
So when you pull all this together, the personal stories, the science grappling with expectation, the legal complexities, the safety warnings, why should you, listening, care about microdosing?
Well, it's just a fascinating window into that complex relationship between mind, body, belief, and substances. It really highlights the challenges of studying subjective experience scientifically.
Yeah, it's where wellness trends meet neuroscience and pharmacology. It forces us to ask tough questions about what really makes us feel better and why. Personal exploration is way out ahead of the science and the law here. It's a really dynamic space.
Yeah.
Okay, from that very personal, subjective landscape, let's make that pivot we talked about. We're now diving into the highly objective, incredibly precise world of cutting-edge medical science, specifically cancer immunotherapy.
Right. And we're focusing on one particular target that's been a game changer, the PD-1/PD-L1 pathway. Blocking this interaction has become, as the source material says, a real cornerstone of modern cancer treatment.
It's led to long-lasting remissions, even cures, for many different kinds of cancer. It's truly been revolutionary.
The drugs that do this currently are mostly monoclonal antibodies, MABs for short. You might recognize names like Keytruda or Opdivo. These are large protein molecules, engineered antibodies.
How do they work, basically?
They bind either to the PD-1 protein on immune cells, specifically T cells, or to the PD-L1 protein that cancer cells often display on their surface. This PD-1/PD-L1 interaction normally acts like a brake, telling the T cell not to attack. So these antibodies block that brake signal.
They release the brakes on the immune system, allowing it to see and attack the cancer.
Exactly. Hugely effective for many patients. But, and this is where the research paper comes in, these antibody drugs aren't perfect. They have some significant drawbacks.
Like what?
Well, for starters, they're biologics complex proteins. That makes them really expensive to manufacture. Cost is a huge barrier.
Okay, so high cost. What else?
There's potential for immunogenicity. Because they're large foreign proteins, the patient's own immune system can sometimes react against the drug itself, reducing its effectiveness or causing reactions.
And side effects. I've heard immunotherapy can have unique side effects.
Yes, immune-related adverse events, or IRAEs. When you take the brakes off the immune system, sometimes it can mistakenly attack healthy tissues too: skin, colon, lungs, endocrine glands. These can range from mild to very serious.
And you mentioned tumor penetration earlier.
Right. Being a large molecules, antibodies sometimes struggle to get deep into solid tumors. They might only reach the cells on the periphery. And the source also notes there's an expectation of potentially higher toxicity when you try to combine these antibodies with other cancer treatments.
Okay, so cost, potential immune reactions against the drug, those IRAEs, maybe not getting into the tumor well.
Yeah.
That definitely creates a motivation to find alternatives, doesn't it?
Absolutely. And that's where the idea of small molecule inhibitors comes in. These are traditional chemically synthesized drugs, much smaller than antibodies.
What are the potential advantages there?
Theoretically, several. Being smaller, they might penetrate solid tumors better. They could have better pharmacological properties overall, potentially even allowing for oral administration.
A pill instead of an IV infusion, that would be huge for patients.
It really would. Plus, small molecules generally have a longer shelf life, and crucially, they're much, much cheaper to produce than complex biologics like antibodies.
Lower cost, maybe better tumor access, maybe a pill. Sounds fantastic.
Yeah.
So why aren't these everywhere already? What's the catch?
The catch, as the paper explains, is the target itself. The place where PD-1 and PD-L1 interact is a large, relatively flat surface on the proteins.
Not like a neat little pocket that a drug can easily fit into.
Exactly. Most traditional drug targets have these well-defined binding pockets. Targeting large, flat protein interaction surfaces like this one is notoriously difficult for small molecules. It's a major challenge in drug design.
So that's why developing small molecule PD-1, PD-L1 inhibitors has lagged behind the antibodies.
Precisely. But this ACS Medicinal Chemistry Letters paper describes a real effort to overcome that challenge. They focused on developing and testing a specific class of compounds they call non-symmetric C2 inhibitors.
Non-symmetric. What does that mean here?
It means the molecule isn't the same on both sides. It's based on a central biphenyl structure, but the chemical groups attached on either side of that core are different. The paper emphasizes this is novel because a lot of previous work focused on symmetric molecules.
Why go for non-symmetric?
Their rationale was that the actual binding site on the PD-L1 protein dimer isn't perfectly symmetric either. So designing a non-symmetric molecule might allow for a better, more specific fit into that asymmetric protein interface, potentially leading to stronger binding and better activity.
Makes sense, like a key fitting a specific lock better if it's not perfectly symmetrical.
Kind of like that. They also highlight the use of an amide linker within the molecule structure, noting it's often considered a privileged linker in drug design because it tends to contribute good drug-like properties.
Okay, so they designed these specific molecules. How are they supposed to work? Do they just block the site like the antibodies?
A little differently, according to their hypothesis and data. These small molecules apparently bind to PD-L1 and cause two PD-L1 molecules to come together. They induce dimerization. And the way these two PD-L1s are held together by the small molecule effectively blocks the spot where PD-1 would normally bind.
So they changed the shape or arrangement of PD-L1 to prevent the interaction.
Essentially, yes. The paper mentions using NMR spectroscopy, which provided data supporting this idea that the molecules cause PD-L1 to form these complexes, or oligomers.
All right, clever design, interesting mechanism. Did they work? What did the tests show?
They ran several key experiments. First was the HTRF assay. This is a test done in vitro, basically in a test tube with purified proteins. It measures how well the compounds can break apart the preformed complex of PD-1 and PD-L1.
So a direct measure of blocking the interaction.
Exactly. And in this assay, many of their new compounds were really potent. They had very low IC50 values. That's the concentration needed to inhibit by 50%, often down in the single-digit nanomolar range or even lower. Really potent in the test tube.
How did they compare to existing compounds?
They used a known reference compound, BMS 1166, and found many of their new molecules were even better at disrupting the complex in this assay. For example, compound 17A caused 83% dissociation of the complex.
Okay. And they found a way to make them even better.
Yeah, an interesting little detail, they found that making the HCl salt form of a couple of the compounds actually improved their solubility and activity in this HTRF test, a common trick in drug development.
So potent in the test tube. But does that translate to working in actual living cells? That's always the big question, right?
Yes, absolutely. And that's why the next test, the cell-based immune checkpoint blockade assay, also called the NFAT assay, is so crucial. This measures if the compound can actually reactivate T cells that are being suppressed by PD-L1 in a cellular environment, much more relevant biologically.
What did they find there?
Also quite promising. Most compounds had EC50 values, that's the concentration for 50% effect, in cells below 1,000 nanomolar. And importantly, the source notes that 79% were below 300 nm. That's generally considered potent enough to potentially stimulate T cells effectively in a clinical setting.
So good cellular activity, too. Did they learn anything about what parts of the molecule were important for that?
Yes, they found the specific chemical group they added to help with solubility really mattered for cellular activity. Linear groups like ethanolamine derivatives worked best, gave EC50s under 100 LEM. More branched or cyclic groups didn't work nearly as well, or sometimes not at all.
That's important because, as the source points out, lots of drugs can look great in simple tests but fail in cells because they can't get in, or they get chewed up too quickly.
Exactly. So showing good cellular activity is a really significant step.
Did they get a picture of how these molecules actually bind?
They did. They managed to get an X-ray crystal structure of one of the promising compounds, 17A, bound to the PD-L1 protein. This gives a 3D picture at the atomic level.
What did it show? Did it confirm their ideas?
Pretty much. The structure, at 2.5 angstrom resolution, shows the small molecule bridging the interface between two PD-L1 molecules, forming an asymmetric dimer, just like they predicted.
You could actually see how it fits.
Yeah, you can see how it makes specific contacts hydrophobic interactions with certain amino acids like TYR56, IL-54, MET115, TYR123, and also hydrogen bonds through its amide linker and a sulfonamide group.
And that's so fun in my group.
Interestingly, that part looked less rigidly fixed in the structure and seemed exposed to water, which they suggest probably helps with the compound's solubility. So the structure really supports the design and mechanism.
So which compound was the best overall in the cellular tests?
That was compound 2. They couldn't get a crystal structure for it, but in the crucial cell-based assay, its EC50 was 21.8 nanomolar. Very potent.
How does that compare to the antibody drugs currently used?
This is where it gets really interesting. The paper states that the cellular activity of compound 2 approaches the activity of durvalumab, which is a marketed PD-L1 antibody. Durvalumab's EC50 is typically in the 0.3 to 1.8 nanomolar range in similar assays.
Wow. So a small molecule getting close to the potency of a large antibody in cells.
Yeah.
That's pretty impressive.
It really is. It suggests these small molecules have genuine potential. So the paper concludes that compound 2, based on all this data, is an excellent candidate for more advanced testing preclinical studies in animals and hopefully eventually clinical trials in humans.
So wrapping up this segment, why should you, the listener, care about all this detailed chemistry and biology?
Because this isn't just scientists playing with molecules. This is about developing potentially better, more accessible tools to fight cancer. If drugs like Compound 2 succeed, they could mean immunotherapy that's taken as a pill, that gets into tumors more effectively, and that costs less.
It's a glimpse at the cutting edge of drug discovery, aiming directly for better outcomes for cancer patients. It's about finding new ways to unleash the patient's own immune system against their disease.
Hope for the future, really.
Absolutely. Okay, so we've gone from the personal and subjective realm of microdosing through the intricate molecular world of cancer drug design. Now, one more pivot, zooming out to the big picture. Geopolitics, international relations, national identity.
Right. Our final source takes us to Taiwan, focusing on that recent visit by a bipartisan group of U.S. lawmakers. The timing, as the article stresses, was key, just days after Taiwan inaugurated its new president, Lai Ching-te.
Can you give us a little context on President Lai?
Sure. He's 65, was the previous vice president. And crucially, the source notes that Lai, like most people in Taiwan, generally favors maintaining the status quo. Meaning, keeping things as they are, Taiwan operates independently, democratically, but without making a formal declaration of independence from China, and also without moving towards unification with China, trying to preserve the current de facto situation.
What did he say in his inauguration speech that was relevant here?
Several things highlighted in the source. He called on China to stop its political and military intimidation. He described Taiwan as a frontline guardian of world peace. He also urged China to, quote, face the reality of the Republic of China's existence, using Taiwan's official name and respect the choices of Taiwan's people.
Did he offer any openings for interaction?
Yes, he expressed hope for dialogue over confrontation and said Taiwan was willing to enhance understanding through exchanges with China, assuming good faith. He also thanked the U.S. and other democracies for their support.
How did China react to Lai's inauguration and the subsequent U.S. visit?
Not well, according to the source. China had already expressed disapproval of Lai and his party. Then, just days after he took office, Beijing launched large-scale joint military exercises all around Taiwan and nearby islands controlled by Taiwan.
What was their stated reason for these exercises?
A Chinese Defense Ministry spokesperson, Wu Qian, was quoted saying the drills were aimed at Taiwan independence forces and were meant to deter external forces from interfering. China considers such actions, quote, entirely reasonable, legal, and necessary.
And the article adds the context that China hasn't ruled out using force for unification, right?
Correct. And it notes that relations had already worsened under Lai's predecessor, Tsai Ing-wen, so the exercises happened in an already tense environment.
So it's into this tense situation that the U.S. lawmakers arrive. What was their official reason for going?
According to a Foreign Affairs Committee spokesperson cited in the article, the bipartisan group planned to meet senior Taiwanese officials mainly to get a direct understanding of the new administration's priorities. Standard diplomatic groundwork, basically.
Were they meeting anyone else?
Yes, they also planned to meet the leadership of the American Institute in Taiwan, or AIT.
That's the de facto U.S. embassy, right? Since the U.S. doesn't have formal diplomatic relations.
Exactly. So they were meeting AIT leadership for oversight purposes and to discuss the overall U.S.-Taiwan relationship.
It's such a unique relationship, no formal ties, yet the U.S. is Taiwan's main supplier of defensive weapons and international backing.
It's a delicate balance. The source notes that even before this lawmaker visit, a bipartisan group of former senior U.S. officials attended Lai's inauguration, signaling that continued strong, albeit unofficial, U.S. support.
And that support goes beyond visits, doesn't it? There was recent action by Congress.
Yes, a very concrete action. Congress recently approved about $2 billion in military aid specifically for Taiwan, aimed at boosting its self-defense capabilities against potential threats from China.
How did Taiwan view this lawmaker visit, coming so soon after the inauguration and amidst the military exercises?
Taiwan's new representative to the U.S., Alexander Yu, was quoted viewing it very positively. He called it a show of the strength of friendship and said such visits are as important as the military aspect because they demonstrate to the other side, meaning China, that people do care about Taiwan.
Okay, so we have Lai's position, China's actions and stated rationale, the U.S. lawmaker's stated purpose, and Taiwan's perspective on the visit. It's really important here, as we always try to do, to emphasize that we're just reporting what the sources say about these different viewpoints and actions.
Absolutely. We're not endorsing any particular political stance here. The goal is simply to convey the information and the different perspectives presented in the source material as clearly and impartially as possible.
Understanding this situation means recognizing these different frames. Lai seeking dialogue while asserting Taiwan's reality. China reacting forcefully to perceived moves towards independence or external support, and the U.S. navigating its complex policy of unofficial ties backed by tangible military and diplomatic support.
It's a very complex dynamic.
So finally, why should you, listening from wherever you are, care about this situation involving U.S. lawmakers visiting Taiwan?
Because Taiwan's status is genuinely a major global flashpoint. Any significant escalation there could have enormous consequences for international stability, for global trade, especially given Taiwan's critical role in producing advanced semiconductors that power so much of our technology.
Yeah, the economic ripples alone would be massive. Understanding the stated positions and actions of the key players, Taiwan, China, the U.S., as reported here, is really vital for anyone wanting to be well informed about one of the most critical geopolitical issues of our time.
Absolutely essential.
Wow. Okay, that really was a journey today, wasn't it? We covered a lot of ground. We started in the very personal world of microdose and psychedelics, looking at user claims and the science trying to catch up with belief and expectation.
Then we took that deep dive into the precise molecular world of cancer drug design, looking at how scientists are creating new small molecules to potentially improve immunotherapy. Really intricate stuff.
And we ended on the world stage, examining the complex geopolitics surrounding Taiwan, China, and the U.S. through the lens of that recent lawmaker visit.
And across all three, we saw this common thread, didn't we? The challenge of interpreting information, whether it's a subjective feeling, complex scientific data, or a political action. How do we separate signal from noise, claim from reality?
Let's just quickly crystallize the key takeaways. From microdosing, compelling user stories meet tricky science, where the placebo effect looms large, all happening in a legally complex and evolving landscape with real safety questions still unanswered.
From the cancer therapy research. A promising path forward, using small molecules to potentially overcome limitations of current antibody drugs, with tangible progress shown in designing potent molecules like Compound 2 that work effectively in cellular tests, offering hope for future treatments that might be cheaper or easier to take.
And from Taiwan, a snapshot of a critical geopolitical moment. We saw the new leadership trying to maintain the status quo while seeking dialogue, China's immediate military response to perceived challenges, and the complex, multi-layered nature of U.S. support. High stakes all around.
Our aim, as always, with the deep dive, is to give you that shortcut. To distill these complex topics from diverse sources, give you the key facts and perspectives, hopefully in a way that's engaging and doesn't feel like homework.
Hopefully we achieved that today.
We covered quite a spectrum.
We really did. So here's a final thought for you to chew on, connecting these threads. Think about how powerful subjective belief is in the microdosing narrative, how the precise objective structure of a molecule determines its medical effect, and how differing interpretations of political signals and national identity fuel global tensions.
Belief, data, perception, consequence.
Exactly. What does reflecting on all that teach you about the gap or maybe the connection between what we believe, what the data says, and the real-world impact of actions and interpretations all around us?
Something to definitely keep thinking about.
On that note, thank you so much for joining us for this deep dive.